So, the United Kingdom is making this huge bet on nuclear power to secure its energy future. But here's the interesting part. It isn't just one single plan. It's actually two. You've got the very real, practical strategy for right now, and then you've got this incredibly audacious dream for tomorrow.
So just how big are we talking? Well, the government's shooting for 24 gigawatts of nuclear power by 2050. Now, to put that in perspective, that's enough juice to power a quarter of all homes in the UK. So yeah, this is a massive, massive national bet on the power of the atom.
Okay, so a goal that big raises a pretty obvious question, right? How on earth do you even begin to build a nuclear revolution like that? Well, the UK's answer is pretty clever. They're basically walking two paths at the same time. One is all about today's technology, what we know works, and the other, it's about reaching for the stars, literally. We're going to start with the here and now.
All right, first things first, we've got to understand the why. What's really behind this huge push for a nuclear-powered future? It all boils down to a few really fundamental goals for the country.
You've got a few really big drivers here. First, energy security. It's all about depending less on imported fossil fuels. Then there's the huge one, hitting that legally binding net zero target by 2050. And look, renewables are obviously a massive part of the puzzle, but nuclear brings something to the table they can't always promise. Super dependable, 24/7 low-carbon power. And crucially, the technology we're talking about, fission. It's proven. It's been working for decades.
Okay, so let's dive into that first path. We'll call it the plan. This is all about nuclear fission. You know, the process of splitting heavy atoms apart. It's the same tech that powers every single nuclear plant on the planet right now, and it's the absolute bedrock of the UK strategy for the next couple of decades.
But hey, having a big, ambitious goal is one thing. Actually, doing it is another. And that's exactly what the Parliamentary Science and Technology Committee said. They basically called the government out, saying, a stretching target requires a credible pathway. And that's not just some stuffy political talk, you know? That's a direct challenge. It puts a ton of pressure on the government to stop talking and start building.
So what was the government's response? They're putting together what they call a nuclear strategic plan. Think of it as a roadmap. And this thing is absolutely crucial because it's supposed to lay out the entire pipeline of projects. The whole point is to give investors and the industry the confidence they need to, finally get to work and start building these new plants.
And a really big part of this modern plan are these things called small modular reactors, or SMRs for short. The whole idea is, instead of building these gigantic one-off power plants, you basically mass-produce smaller reactors in a factory. Then you just ship them out and assemble them on site. The dream here is to make nuclear power way faster, way cheaper, and a lot more flexible. Of course, there's the elephant in the room. Money. None of this happens for free. We are talking tens of billions of pounds here. So the multi-billion-pound question for any of these projects is, how do you actually pay for it? And maybe more importantly, who takes on the huge financial risk of building it? So for a while, the main model was something called Contract for Difference, or CFD. With this one, the company building the plant takes on all the risk. They don't see a penny until the plant is up and running. The problem? That is a ton of risk, which makes borrowing money incredibly expensive. So to fix that, the government is shifting to a new model called the Regulated Asset Base, or RAB. And here's the key difference. The risk gets shared. We, the consumers, pay a tiny bit extra on our bills while it's being built, which, and this is the important part, dramatically lowers the cost of borrowing the money in the first place. And if you're wondering why they'd make that shift, well, here it is. The government's own numbers show that using this new RAB model could save over £30 billion on a single new plant. I mean, that is just a staggering amount of money, and it's pretty much the main reason they're changing their strategy. Now, we can't talk about fission without talking about the waste. It's the reality of the technology. And while the current storage is totally safe and secure for now, the final, permanent solution, a deep geological disposal facility, well, that's a massive project in itself, and it's probably not going to be ready until the 2050s at the earliest. Okay, so that's the plan, based on today's tech. But remember, there were two paths. So now let's talk about the dream. We're shifting gears to fusion energy. If fission is the reliable workhorse we have now, fusion is the holy grail. It's a much, much longer shot, but the payoff could literally change the world. So what is fusion? In the simplest terms, it's the power of the sun. It's what's happening in every star in the sky. Instead of splitting big, heavy atoms apart like we do in fission, fusion is all about smashing tiny, light atoms like hydrogen together. And when they fuse,
Boom, they release an absolutely incredible amount of energy.
But trying to build a tiny star here on Earth? Yeah, that's an unbelievable challenge. Scientists have to get this recipe just right, and it has 3 main ingredients. First, you need insane temperatures. We're talking over 100 million Kelvin. That's hotter than the core of the sun. Second, you need crazy high pressure to squish the fuel together. And third, you have to hold it all in place long enough for the fusion to actually happen.
So how does it actually work? Well, the most common approach uses 2 types of hydrogen for fuel. You take them, you superheat them into something called a plasma. Then you use massive forces to slam those atoms together. When they fuse, they release a huge burst of energy. And that energy, that's what we can capture as heat to generate electricity. And the main thing left over? Just harmless helium.
And let me be clear, the UK isn't just idly dreaming about this. They are putting serious money where their mouth is. Public investment is already in the billions, with hundreds of millions more already earmarked for the next few years. This isn't just some side project. It's a major, long-term national commitment to try and make fusion a reality.
All right, so now we've got our 2 paths clearly laid out. Fission, the plan, and fusion, the dream. So let's put them side by side. It'll help us really get why the UK is actually trying to do both at the same time.
Okay, this really gets to the heart of it. Fission splits heavy stuff like uranium. Fusion joins light stuff like hydrogen. That right there leads to a huge difference in waste. Fission leaves behind long-lived radioactive waste. Fusion's main byproduct? Helium. That's it. The safety is also totally different. A fission reactor has a theoretical risk of meltdown. A fusion reaction, if the containment fails, it just stops. But here's the biggest difference of all, and it's the most important one. Fission works right now, today. Commercial fusion is still decades away.
And this is why fusion is the ultimate goal. The fuel is basically abundant. You can get it from seawater. The process is inherently safe. There's no chain reaction that could run away. It produces 0 long-lived radioactive waste and no greenhouse gases. I mean, if we can finally crack the code on this, it's pretty much the ultimate source of clean, sustainable power for humanity.
So, when you put this all together, what does Britain's nuclear future actually look like? Well, it looks like this dual-track strategy. It's a really careful balancing act between what we need right now and the incredible promise of what could be.
So here's the strategy in a nutshell. Use the plan to hit the 2050 goal, and use the dream to secure the long-term future. It means rolling out proven, reliable fission technology, including those new SMRs, to meet those urgent climate and energy security targets, and at the exact same time, it's pouring billions into fusion research to try and be a world leader when that breakthrough finally comes.
And that really leaves us with a big question, doesn't it? By going down both paths at once, the proven one with fission and the high-risk, high-reward dream of fusion, has Britain placed the right bets? It's a strategy that's very grounded in today's reality, but it's also reaching for a total revolution tomorrow. We'll just have to wait and see if it all pays off.